In this presentation, we're going to look at hominoid origins. Now, that's another level in the Linnaean hierarchy, remember? And in this case, it includes apes and humans. Fossil apes, living humans, fossil humans. So, we know an important event happened somewhere back after Old World monkeys branched off. And that was the loss of a tail. Because if anyone asks you what's a single major difference between us and monkeys, it's the fact that apes and humans have no tail, monkeys have tails. Now, the Miocene was a geological expanse of time that was between about 23 million and about 5 million years ago. That's called the Miocene. And it was during this time when we began to see the emergence of the hominoids, particularly apes. And the Miocene, as you will see, there were so many different kinds of apes. Today we have chimps, gorillas, orangutans, and gibbons. Back then there were probably tens of species spread throughout Africa and Asia and Europe, interestingly. So divergence times have been estimated on the basis of similarities and differences in nuclear DNA. As you see, there's a reference to Stauffer in 2001. And it is suggested that Old World monkeys diverged about 23 million years ago. About 15 million years ago, we saw gibbons, which are called hylobates. Gibbons are one of my favorite primates. Orangs, and we've got some fascinating material on orangutans, diverged about 11 million years ago. Gorillas branched off maybe 6 million years ago. And humans and chimps separated at 6 million years ago, somewhere between 6 and 10 million years ago. We don't know exactly when that happened. And that's something that we may touch on again later. So where and when did apes evolve? The earliest evidence of fossil apes does come from Africa. It comes from the early part of the Miocene, which is 17 to 22 million years ago. There was a great diversity of fossil apes. There were more than 10 different genera, okay? So, and each one of them had a number of species, or at least 15 or more species of apes known during this period. And in this early Miocene, it was the first of two major adaptive radiations. We talked about what an adaptive radiation is earlier, of apes in the Miocene. And multiple species were often found at the same site, such as where the genus Proconsul was found. These ranged in size from just smaller ones, 3.5 kilos, to 10 kilos. 10 kilos would be something like 23, 24 pounds. Not huge, but larger in size. In the early Miocene, there was a great diversity of primates, particularly apes, not as many monkeys, interestingly. Monkeys didn't really diversify until somewhat later. East Africa was probably very heavily forested. The prevailing winds that came from the west were carried with them lots of moisture, and the tropical rainforests that are typical today of Central and West Africa extended almost all the way over to the Indian Ocean. So this was a major band of thick, heavy, dense tropical rainforests. And this is where these monkeys were, or these apes were undergoing an adaptive radiation into a whole series of apes. We don't know much about what happened in West Africa, unfortunately, because there are not really good geological sites there like there are in Eastern Africa. And as I said, there weren't very many monkeys. So this really was the planet of the apes. Now, in East Africa, something was happening during this time, something momentous, something that had a major influence on the climate of Africa, particularly East Africa. And this was the beginning, about 20 million years ago, as you can see, of the East African Rift Valley, one of the most stunning features geologically on the face of the earth that we will look at in some detail. And the highlands to the west of the rift, you see the rift going up through here, whoops, wrong end of the pen, the rift over here, coming up out of what is Tanzania today into Kenya and right on up into Ethiopia, intersecting the Gulf of Aden and Red Sea. And that was formed largely by the fact that the Horn of Africa, and you can see that this does look like a horn just right there, the Horn of Africa is moving away from Africa. It's a subplate of the African shield. And it was beginning to thin the crust and beginning to develop this rift, which is called the East African Rift Valley. And what that did also was it released a lot of volcanic activity. The crust had become thin, and all those little red triangles are volcanoes, some of which are active today. If you go to East Africa, particularly Tanzania, you see active volcanoes, and up in the Afar region of Ethiopia, at the northeastern terminus of the Great Rift Valley, you can look down into these huge volcanoes like Ertale, where you see a lake of bubbling lava. It's quite remarkable, very dramatic. And it began to develop, to build highlands to the west of the rift and stop that heavy moisture from coming over into the rift, and it began to change the climate so that the eastern part was losing its forests and beginning to develop more open areas, which presented a whole new set of environments for individuals to evolve, and particularly early humans. Now, I talked about a feature of the hominoids, of apes and humans, in my previous lecture that we call the Y pattern, and I think you see it very clearly here in yellow, that you have two branches, our teeth. This is looking down on the chewing surface of in this case, a chimpanzee, and you can see that there's 1, 2, 3, 4, 5 cusps. These are, actually the cusp is there, these are major cusps. These are the little bumps you feel when you rub your tongue over your lower molars. And they're arranged in a Y pattern, and that is very characteristic. It was first noticed in a genus of ape from Europe, which was called Dryopithecus. And sometimes it's called the Dryopithecus pattern. And it's something that unites all living apes and fossil apes and humans. So that must mean, in terms of ancestry, that the common ancestor to all of us and the apes possessed that feature, and it has been inherited to the present day. So that feature, when we look at it in apes and humans, is a homologous feature because it was present in the common ancestor. Now, when you look at hominoid postcranial, there are really two different ways to describe this. On the one hand, you have monkeys that walk around like your dog, right? They walk around pronagrade on all fours, which is called quadrupedalism, right? 4 feet. Hominoids, most hominoids, on the other hand, are orthograde. They're more vertical. We are very vertical because we walk upright. We walk bipedally, and we're going to spend a lot of time talking about that. It's a fascinating adaptation. No other animal does it. And or they are suspensory. They hang below branches. And if you go to the zoo, or better yet, go to East Africa and look at chimpanzees, you'll see how they're hanging underneath the branches. They'll walk on top, but they have this special adaptation, which is suspensory. Chimps and gorillas, by the way, are very interesting because they spend a lot of time on the ground, especially gorillas, and they have an adaptation that's very different from the quadrupedal monkeys. Rather than walking on the palms of their hands, as monkeys do, they walk on these knuckles, and they walk like that. And this is what's called knuckle walking. I think we'll return to that, but it's a very interesting adaptation to living in the forest floor, for example. Now, apes in general, as opposed to monkeys, a mandrill is a West African monkey, a beautiful animal. It's very colored face, a very, very long projecting face. But what can we do that monkeys don't do? And what does the suspensory posture enable us to do? First of all, it flattens our chest from front to back and makes it wide from side to side. If you look at what's your most favorite quadruped? For many of you, it's probably your house cat or your dog or something like that. They have very narrow chests from side to side. And they don't have the mobility that we do and that apes do. So with apes or hominoids, we have increased shoulder, hip, wrist, and ankle mobility. We don't have a tail. We have long upper limbs, and we have a short, stiff back. So that if you take the family dog, for example, family dog can't do that with its arm, can it? It'll squeal, it'll make noise if you try to pull its arm out like that. It only goes backwards and forwards. So our ancestry is somehow tied to the suspensory arboreal kind of creature. That's how they got around. Well, proconsul is one of the possibilities. It's found in Kenya, a number of species. I think there are at least 4 species of proconsul now, and various sizes, that lived some 17 to 20 million years ago, but they were very monkey-like in the sense that they had a very monkey-like face and head. They had a lightly built cranium. They didn't have brow ridges like apes, and they had very projecting monkey-like faces. They were much different in size, males and females, which is called sexual dimorphism, with males being larger, females being smaller. But they did have that Y pattern, they didn't have a tail, and they are a candidate for an ancestor to later apes. As I said, males are 1.3 times as large as females. In terms of the postcranial anatomy, and what we mean by that, you have the cranial anatomy, which is this, and then you have the postcranial, which is below the neck. It was very monkey-like. And there are some ape-like characteristics to it. And it suggests that they were probably living in the trees, arboreal, that they were walking on all fours, probably on tops of branches, not suspensory, using those grasping hands and feet to stay on top of those branches. And very importantly, there is no evidence, as you can see, for a tail. So what happens just after proconsul, or around that time? There is a reduction in the number of lumbar vertebrae down in your lower back. There's a loss of the tail. There is a predominance of Y5 patterns on all the molars, and significantly increased shoulder as well as hip mobility. So this is the little we know about the origin of the hominoids, which includes the origins of the apes and ourselves.